Okay, quantitative literacy. This is the second part of the 10.3 notes. We're starting on number 6. We have secret lab. The ID numbers have 4 digits. Okay, so we're going to deal with that first. It does say later on, no repetitions are allowed within any of the groups. So my 4 digits, since the number 1, 2, 3, 4 entered into a keypad is different than 4, 3, 2, 1. This is a permutation again. So it's a permutation because the order of the numbers will matter when I enter them into the keypad. Well, there are 10 digits, remember 0 through 9, 10 digits, and I'm picking 4 of them. For the second part, then there's 2 letters. So AB is different than BA, so that's going to be another permutation. There are 26 letters to choose from, and I'm picking 2. Finally, there's 3 more digits. So that's going to be permutation of 10 choices, picking 3. Just like I did on the baseball problem, I'm going to multiply these all together. So if you calculate each one of these, permutations of 10 choose 4 is 5,040. Permutations of 26 choose 2, 650. And finally, 10 choose 3 is 720. I'm going to multiply all those together. Notice we'd be getting a lot of big numbers. This is going to give you 2,358,720,000. So it's hard to crack the code for the secret lab. There's a lot of different options. On the next page, we've got a few problems to deal with poker hands. We're going to deal with poker hands a lot when we're talking probability in the next unit, but they start to show up here. First thing is make sure you're aware of the different cards in poker. We have 2 through 10, then Jack, Queen, King, Ace. Each one of those has 4 different suits. We have hearts, we have diamonds. I don't have the black pen, but we have spades, and we have clovers. So on letter A, how many hands have 3 hearts and 2 non-hearts? Okay, we already talked about that in poker. A poker hand, it doesn't matter what order I receive the cards. I have 5 cards. So since order does not matter, these are going to be combinations. So if I look at the 3 hearts, again, it's going to be combinations now, not permutations. The order doesn't matter. Well, since there's 52 cards split up in 4 different suits, 52 divided by 4 is 13. So basically each suit has 13. So 3 hearts. There are 13 hearts total. I'm choosing 3 of them. For the second part, 2 non-hearts. Again, we're talking combinations here. Well, if there are 13 hearts, there are 39 cards that are not hearts. I'm going to choose 2 of those. You'd figure out each one of those individually and multiply them together, and you'll get 211,926. On letter B, how many hands have 4 face cards? Okay, face cards are the Jack, the Queen, and the King, because they have faces on them. They're people. Well, there are 4 of each one of those. There's 4 jacks, 4 queens, 4 kings. So 4 times 3 is 12. The 4 face cards, there are 12 face cards. I'm picking 4 of them. And then I'm going to multiply that by 1 non-face card. If there are 12 cards that have faces, 52 minus 12 is 40. There are 40 cards that do not have faces. I'm picking 1 of them. Again, you do each combination separately in your calculator, multiply them together, and you get 19,800 possibilities. Oh, I just realized I said clover earlier. Those are clubs. It looks like a clover, but it's called the clubs. How many hands have 2 red cards? Let's see if I can change this over to red on this one. Here we go. 2 red cards, 1 spade, 1 club. Okay. So 2 red cards. Well, red cards are either hearts or diamonds. There are 13 hearts, there are 13 diamonds. That's 26 total. So this first part is combinations of 26. Pick 2. 1 spade. Spade is not a red card. There are 13 spades. Again, there's 13 of each suit. I'm picking 1 of them. And there are 13 clubs. I'm picking 2 of them. So you would calculate each one of these combinations separately, multiply them together, and you get 329,550. 329,550 ways. Number 8 is actually kind of a tricky problem because even though it's called a combination lock, this problem is not a combination problem. I can't use the combination thing. I also can't actually use the permutation thing. The reason being is on a combination lock, repetition is allowed. So this is neither a permutation nor combination. It's what we did before break. Basically, there's 3 numbers on this combination lock. Repetition is allowed. You could technically have the combination 0, 0, 0 or 10, 10, 10. So there are 40 options for the first number, 40 options for the second number, 40 options for the third number. So it's just 40 times 40 times 40, which is 64,000. Do not worry about number 9. That's a real tricky problem. I'm not going to put that on the exam. So that will do it for the 10.3 notes.